Let's do one more problem where we try to find the zero of a function. And we're going to first estimate this by graphing. And then after we do an estimate by graphing, we're going to use algebra to figure out exactly what it is. So the problem says Emily's going to a local carnival. The function m equals 20 minus 0.75r represents the amount of money m she has left after r rides. Find the zero, describe what it means in context, identify the domain and range, and describe their significance. Okay, so step one is to graph it. So let's make our x, y table. Again, we can choose any values we want for this table. I always start with 0. You don't have to. You don't have to use 0, but boy, is it easy to plug in and then multiply by 0. 0.75 times 0 is 0, and 20 minus 0 is 20. So our first coordinate is going to be 0, 20. Let's go ahead and put that on there. 0, 20. Great. Okay, so since we're multiplying by a decimal, a good second point to pick would be like a multiple of 10, just because multiplying a decimal by 10 is easy. 0.75 times 10 is 7.5, and 20 minus 7.5 is going to give us 12.5. So our next point is 10, 12.5. I'm going to have to estimate where that is because my graph is not quite accurate enough to get down to the 0.5. So that seems like a reasonable estimate, a little bit higher than 10. I need one more. Let's go ahead and do 20. So 20 minus 0.75 times 20. Well, if 0.75 times 10 was 7.5, then 0.75 times 20 is going to be 15. So this is 20 minus 15, which is 5. So 20 and then 5 is going to be my third point. I think that's enough points. They look like they're in a straight line. That middle point is a little suspect just because I had to estimate, but pretty decent estimate. I am only going to do my line in the first quadrant here because she cannot have negative amounts of money or do a negative number of rides. So we want to limit ourselves to the first quadrant. And then our zero of the function is right here. So it looks like that's maybe, looks a little higher than 25 to me. I'm thinking like maybe this is about 26 to 27-ish. Could be 25, but an estimate from our graph says it's about 26 to 27. Let's use algebra to figure out exactly what it is. And the way that we do that is we take our original equation, m equals 20 minus 0.75r. And what we want to know is when is the y-intercept? And in this case, the y is measured by m, the amount of money. Money is our dependent variable. The amount of money she has depends on how many rides she goes on. Let's go ahead and label our graph actually. This is money. And the problem doesn't say, but let's assume dollars. And then this would be number of rides. Okay, so we want to know when's she going to run out of money. So let's take this equation and replace the m with 0. 0 equals 20 minus 0.75r. So we're going to isolate the r. We can either subtract 20 on both sides or add 0.75r on both sides. And I'm going to add 0.75r so that I have, number one, positives, and number two, so that the r is on the left side. This is the addition property of equality. 0.75r added to 0 is 0.75r equals 20. So what this is telling us is she's got $20 and every ride costs 75 cents. That's this equation in pure English. Every ride 75 cents. So to figure out how many rides she can go on, I swear, I cannot speak English. We divide by 0.75. This is the division property of equality. So we want to do 20 divided by 0.75. This is not going to come out to be a whole number. It comes out to be 26. believe it's 26.6 repeating. Let me double check. Yeah, 26.66. Okay. Now here's the thing. This place is not going to let her go on 0.66 rides. So 26.66, although it is in between our guess of 26 to 27, they're not going to let her do part of a ride. So what this means is that she's going to spend 75 cents on every ride, and then she's going to get to the end of the day and she's going to have some money left over, but not 75 cents. She's not going to have enough to do one more ride. So should we round up to 27? No, because if she doesn't have enough money to do the ride, she can't go on that 27th ride. So this means she can go on 26 rides. And this is an instructive problem for that exact reason. Just because a number ends with 0.66 does not automatically mean that we round up. We have to pay attention to the problem in context. It doesn't make sense to round up here. She cannot go on a 27th ride. She won't have enough money. Okay, so she can go on 26 rides. Now the problem also asked us to identify the domain and range and describe their significance. Okay, so the domain is the number of rides. Mathematically, the domain is from 0 to 26.66666. But logically, the domain is from 0 to 26. And so what we're going to say here is the domain is, and we're not going to use x because the problem doesn't use x. The problem uses r for the variable. So we're going to say the domain is r such that r is between 0 and 26. Mathematically, it's 26.66666, but in the context of the problem, that does not make sense. Okay, what about her money? Well, she's got $20. And so her money, which this is the range, which is the y values, but the problem used m for our y variables. We're going to say m such that her money's always going to be between 0 and $20 inclusive. So m is between 0 and 20. And what that means is the most amount of money she has is 20, and the least amount she could possibly have is 0. And so that's the domain and range in the context of this problem.